Kia ora, here's day 3 of your holiday practice. 3 more trig questions. The first one's a really easy equation solving question. Use general solutions for that one. The second one is also straightforward, but good practice at what we mean by exact values, which some of you need to remember from our recent test. And the last one is a little identity proof, and I'll give you a clue for that one, the sums and products rules that you love so much. Okay, so pause the video, have a go at them, and then I'll go through them on the next slide. Right, so we have to solve this. So we're working with a quadratic equation in cos of x. It's a pretty straightforward one because we've got a common factor of cos x, so we pull that out the front. So cos x times 2 cos x plus 1 equals 0. Now if either this is 0 or this is 0, then the whole thing will be 0. So working first with cos of x equals 0. Well, what's alpha? My principal solution to that one is pi on 2. So using my general solution for cos, I get x is equal to 2n pi plus or minus pi on 2. And just remember what's going on there with the symmetry of the cosine graph is that I'm going every 2 pi and then I'm going backwards and forwards by pi on 2. So that's going to generate all of those solutions in both directions forever. Okay, so that's that part done. Secondly, we've got 2 cos x plus 1 equals 0, which gives me cos of x is equal to negative 1/2. So alpha is equal to this, and that works out to be 2 pi on 3. So x is equal to 2n pi plus or minus 2 pi on 3. Now just remember how that links up with our definition of cosine. Cosine is equal to x over r. So we're looking for the angle that's going to give me x over r is negative 1 over 2. So there's my first one. So here's negative 1 here and 2 here. You can see that's my principal solution of 2 pi on 3, and down here as well, negative 2 pi on 3, and all revolutions of those as well. Okay, so my answer to this problem is these values of x and these values of x. All of those will make this equation true. Okay, on to the exact values question. Right, well, we're given an exact value for sine of pi on 10. So we need to use that to find the cosine of pi on 5. So what's the link between pi on 5 and pi on 10? Well, cosine of pi on 5 is equal to the cosine of 2 times pi on 10. So we're going to apply one of our double angle formulae. So we've got 3 to pick from. We've got cos squared minus sine squared. We've got 1 minus 2 sine squared. And we've got 2 cos squared minus 1. So which one's the best one to pick? Well, it's pretty obvious. We've got sine of pi on 10 up here, so we're going to choose this version of the double angle. So substituting that in, we get 1 minus 2 sine squared of pi on 10, which gives me 1 minus 2 times 1/4 root 5 minus 1 squared. One of the reasons I picked this question today was to give you some more practice with surds. So here we have 1 minus 2 over 16, right, squaring this, times, well, let's see, what have we got? Root 5 squared gives me 5. I've got 2 times this middle term here, so minus 2 root 5 plus 1. So that gives me 1 minus 6 minus 2 root 5 on 8, which is 1 minus 3/4 plus 1/4 root 5. I'm trying to squeeze this all onto one slide, so let's now clean it up. So our final answer is 1/4 plus root 5 on 4, or if we want to write it in the same way that we started with our exact value, 1/4 times root 5 plus 1. Okay, but I would give a full mark to this or to this. Both are good. Lovely maths. Right, on to the last question, and then that'll be it for today. Okay, we're asked to prove this statement. Sine squared 3 alpha minus sine squared alpha equals sine of 4 alpha times sine of 2 alpha. So there's probably lots of different ways to do this, but I like to use the difference of two squares when I spot it, and this is a nice example of it. So we've got a squared thing here, and we've got a square thing here. So starting on the left-hand side, sine squared 3 alpha minus sine squared alpha is equal to sine 3 alpha plus sine alpha times sine of 3 alpha minus sine alpha. So now I know that I can use, or try to use, my sum to product rules, because I've got sine A plus sine B, and then sine A minus sine B. So what are my rules for those? Well, using P and Q, we've got sine of P plus sine of Q is equal to 2 sine half the sum times cos half the diff. Remember, we proved these in class. And then the other one I want to use is sine of P minus sine of Q, which is 2 cos half the sum times sine of half the diff. So pause the video if you haven't got there already and apply those two formulae, and you should get the whole way there with one more little trig identity along the way. Okay, so we'll pop that in a box and we'll just keep going with the black pen. So the first one turns out to be 2 sine 3 alpha half the sum, 3 alpha plus alpha on 2, cos 3 alpha minus alpha, oh, what's happened, minus alpha on 2, times, what have we got now, 2 cos half the sum, 3 alpha plus alpha on 2, times sine of half the diff. So 3 alpha minus alpha on 2. Now I like to always write those out, even though you probably can do them in your head. It's easier to spot your mistakes later on if you've done full working. So that now gives me 4 sine 2 alpha cos alpha cos 2 alpha sine alpha. So we're not quite there, but let's look at where we're getting to. We want to end up with sine of 2 alpha here. And we know that that's 2 sine alpha cos alpha. So we can see that we're going to regroup in here. We're going to split that 4 up into 2 2's. We've got cos alpha and sine alpha, and we've got cos of 2 alpha and sine of 2 alpha. So now we're going to have 2 sine 2 alpha cos 2 alpha times 2 sine alpha cos alpha. And I'm just going to be able to squeeze that in. Right, so there we've got sine of 2 times 2 alpha, which is 4 alpha, times sine of 2 alpha, which is the right-hand side as required. Alright, that's all for today. Thanks for watching. Make sure that you've done these a couple of times over so that they're feeling really, really easy.